Hey, this is the continuing with the notes with chapter 5.5, derivatives for exponential functions of base other than base e, base a. Um, Now, exponential function and not log functions, they're inverses of each other, so they have a way of canceling each other out if we take the composite functions of each other. And so here's one property: e to the ln of a is equal to a. So um, basically, if I'm plugging a natural log function into exponential function of base e, the base e are going to cancel out, leaving us with just a. So e ln of a is equal to a. We'll use this property to prove the rule for this exponential function for base a to the x. So if I have the derivative for a to the u, there's this component that it is not base e, so there's a natural log of a, but then the remaining is going to remind you a lot of the rule for e to the u, which is e to the u times u prime, but in this case base a, so a to the u times u prime. So our derivative for a to the x, if we can prove this, is we know that a, right, from before, in terms of e, we can write this as e to the ln of a. So if we replace a with e to the ln of a, we have e to the ln of a times x. Okay, so let's find the derivative for this expression here. E to the ln of a times x. So think of this as a coefficient multiplied by x. So the derivative for e to the u, this whole thing is u, is e to the u times u prime. So the derivative of a constant or coefficient times a variable to the first power is just going to be that coefficient, right? E to the 3x will simply become e to the 3x times 3. So therefore e to the ln of ax derivative will become e to the ln of ax times ln of a. So there's that ln of a component that will be part of the derivative rule for a to the u. Now, e to the ln of a, again, this represents a, so I can think of that as a to the x. So our rule for a to the u will simply be ln of a times a to the u times u prime. Okay, so if you compare this with the rule for e to the u, you're going to see a lot of similarities here. E to the u becomes e to the u times u prime. A to the u is a to the u times u prime with this extra portion to account for the fact that it is not base e. There's that conversion process, so ln of a. Okay, let's just look at two examples here. 5 to the x squared minus 2x, we can apply the derivative rule for base 5. So simply our a is base 5 represents the a value, so ln of 5, natural log of 5, times a to the u, the original function, times the exponent's derivative. So x squared minus 2x becomes 2x minus 2. Okay. Example 6, f prime of x. If we want to find the derivative for this, we have to go through product rule. Notice that x and 4 to negative 2x are put next to each other using being multiplied together. So we have to go through product rule if we want to find the derivative. So f prime g. So here f prime g plus f times g prime. So now the derivative for 4 to the negative x, we are going to apply the rule for a to the u. So ln of 4 times 4 to the negative x, the original function, times the exponent's derivative times negative 1. So if we clean this up a little bit more, we can move the 4 to the negative x to the denominator as 4 to the x. So 1 over 4 to the x minus x ln of 4 over 4 to the x. Write this as one fraction, so 1 minus x ln of 4 all over 4 to the x.